Hi, we are from Group 30. Today we will discuss about the real gases and its application. Let me introduce myself first. My name is Siti Shamira binti Hasbu. My metric numbers is 158137 and these are my group members. Husna Safia binti Ahmad Tajuddin, Sarah Nabila binti Muhammad Zahidi, Nur Afika Batrisha binti Azmi and Yusrina Najwa binti Yaakob. A gas that behaves differently from an ideal gas is typically referred to as a real gas. The interaction of the gaseous molecules help explain their behavior. Real gases do not obey the ideal gas law due to intermolecular interaction between gas particles. Real gases can behave differently than ideal gases, especially at high pressure and low temperature. The compressibility factor is used to calculate the extent of deviation.
Hi, my name is Nasafia. For the application of the regas for a hydrogen tank filling process, as we know, the high pressure gases hydrogen storage method is frequently applied because the hydrogen gas has a low density at room temperature and atmospheric pressure. So, how does the application work? By using the condensation of the real gas, the real gas deviate from the ideality of high pressure and low temperature. At constant temperature, hydrogen gas confined in a tank is filled until it's compressed so much that it began to liquefy or condense. At some point, the hydrogen gas and liquid coexist. This means known as the critical point where we cannot distinguish the separation boundary, and the hydrogen gas exists at the single phase denser than a gas known as supercritical fluid.
Hydrogen tank filling process application is implemented as a real gas model. What can relate with what we learned? Okay, for parameterization, first, the long parameter model used to simulate the filling process and time-independent temperature evaluation curve. Secondly, the specific internal energy and the heat capacity as well as the pressure and temperature in the critical state are additional factors for developing a real gas model. According to the study, filling rate, filling duration, and temperature of pressure and hydrogen supply temperature are the main factors affecting tight ID and storage quantity. Computational fluid dynamic simulation both assess the impact separately and jointly. These parameters are taken for consideration when creating a prediction model. Other than that, we also can relate with the Joule-Thomson effect. First, a change in temperature can be observed when a gas expanded from a high pressure over an isentropic bath. An ideal gas model cannot explain with this behavior since it does not model a pressure dependency of the specific enthalpy. The effect is described by the Joule-Thomson coefficient as shown. The relationship between Joule-Thomson coefficient and the specific heat, pressure, volume, and temperature during a throttling process is as given. We also can relate this application with internal pressure. The change in temperature, pressure, charge volume, and internal and external HPT temperatures were explained by infusing compressed hydrogen into hydrogen-containing high-pressure thermoelectric turbine (HPT). By using analysis and numerical process, the high-pressure storage tank technology employed in hydrogen station was investigated.
The benefits, real gas have volume and can be compressed. Liquids and solids require molecules to have a volume. Real gas like hydrogen is very amenable to compression and can be liquefied. Thus, the volume can be reduced by 94%, saving more space. Next is high diffusivity. Gas particles can quickly diffuse throughout a container due to their high mobility and the lack of strong attractive forces between the particles. Lastly is low density. Gases have a low density because their particles are widely spaced and there are a lot of empty spaces between the particles.
For conclusion, a real gas is one that disobeys the gas laws under any standard pressure and temperature conditions. When we comparing the real gas have mass, velocity, and volume, while ideal gas does not have mass, velocity, and volume. When compared to the overall amount of gas, the space that the gas occupies is very little. Real gas does not behave like an ideal gas. These interactions of the gaseous molecules can be used to explain their behavior. For the equation of real gas, the equation is P plus n power of 2 times A over V power of 2 and times with the V minus NB equals to nRT. For the application of real gas, as we discussed, the application of real gas is hydrogen tank filling process. This process is referring to the high pressure gases hydrogen storage method that is frequently used because the hydrogen gas has a low density at room temperature and also at atmospheric pressure.